what you're going to find is that there's a lot of variants out there. How important they are is all going to be dependent upon looking for certain mutations now that we're starting. There's a collection of them that turn out to be important that are in this receptor binding domain. There may be other ones that are important too that we haven't fully figured out that are also in the spike protein. They could be somewhere else in the virus too. So there's still a lot of room to figure everything out. But all the focus is in this one area, and that helps to differentiate in this receptor binding domain. That's differentiating the UK variant from the South African variant from the isolates that are coming from Brazil. There's all mutations, and there's a lot of them. It's just not one or two. There's clusters of them, 8 or 9 mutations. So we still haven't figured out all of them, but there's several of them that always show up, and they fortuitously turn out to be associated with resisting neutralizing antibodies, which is what my guess is that that's the reason why they've been selected for, because that's something that's stopping the virus from doing something. And viruses will mutate to get around obstacles, roadblocks, like an antibody. That makes sense. Yeah, it could make sense too that they're smart and they're trying to be able to be transmitted from one. They are pretty smart, but they're probably not that smart. But it could be that the reason why they could be more pathogenic and cause greater disease, that if they bind to the ACE2 protein more efficiently, that could allow them to spread more efficiently in a lung. So that might be a reason why. I've not heard anybody say that, but it might make sense as to why they might be a bit more virulent in certain instances.